Moving right along here. Another theorem that we learned here is that an inscribed angle subtends a semicircle if and only if the angle is a right angle. Remember the if and only if, biconditional. So what this is saying is if you've got an inscribed angle and the arc that is created here, or that it subtends, if that is a semicircle, then the measure of this angle is 90 degrees. Makes sense, doesn't it? Because if that is a semicircle, that means the measure of that arc would be 180. Therefore, its inscribed angle obviously will be half of that 180, so that will be 90 degrees. How we will apply this is something here. If we were to find just A, now notice how we're just finding A. In this circle here, you've got that WY is a diameter, meaning that arc WY is a semicircle. Therefore, since this intercepted arc is a semicircle, the measure of this angle must be equal to 90 degrees. So what we can do is set the 5A plus 20 equal to the 90 degrees. Yep, that's a 90. And then we'll just go ahead and solve that. So we'll subtract the 20 from both sides. We get 5A equals 70. Divide both sides by the 5. And what we get for A, which is what we were supposed to find, we would get 14. Alright? So we can kind of use that same idea here. Here we've got, again, a diameter, which means the measure of this arc is 180 degrees. So what I would do here is I would set, let's go with a different color, I would set the 8Z minus 6 equal to 90. Okay, and if you go ahead and solve that, you're going to add the 6 to both sides, so you get 96. Divide both sides by 8, you would get Z, make this actually look like a Z, is equal to 12. Alright. Now down here, a little bit more challenging, we are to find the measure of angle EDF. So for EDF, if we were to find the measure of that angle, well, we're kind of going back actually to an earlier theorem which says this. Let's take a look at EDF. EDF intercepts this arc. We'll notice how that arc is actually intercepted by both of these angles, which means since both of these angles are inscribed and they intercept this same arc, then these two expressions would actually be equal to each other. Let's extend this a little bit. So I would set the 2x plus 3. Sorry if you are hearing, and I'm sure you are, the mouse here. With time, that will get fixed. Okay, so I'm going to add the 2x to both sides. I get 4x, and I'm going to subtract that 3 from both sides, so equals 72. Therefore, x is equal to 18. Now that's just x. So for the measure of EDF, what I'm going to do is I'm going to plug 18 into there. So I would get, for the measure of angle EDF, I would have 2 times 18, which of course is 36, plus 3, which is equal to 39 degrees. Some of you probably didn't even notice the mouse clicking until I actually said that. Others I'm sure did. Okay? Just in case you need a break. Okay. Now, another theorem here is the fact that if a quadrilateral is inscribed, now inscribed means it's on the inside of that circle and each of the points are actually on the circle, then the opposite angles would be supplementary. Now this kind of makes sense if you think about it. If you look at angles D and B, well, these are on an inscribed quadrilateral. That means these two angles would be supplementary. Of course they are, because if you look at this arc AC and then add that to the arc which is intercepted by angle D, which would be the other portion of AC. Between the two of them, that is 360 degrees, meaning that their arcs themselves would total 180 degrees. So that means that they are supplementary. Okay, so let's apply that here. We've got opposite angles which are going to be supplementary. Now, to be supplementary, that means that they're going to add together to give us 180. So I would set the 6b plus 20, add that to the 3b plus 25, and that is to equal, since these are supplementary, that is to equal 180 degrees. So if I combine everything here, I get 9b plus 45 equals 180. I continue to solve. I'm going to subtract that 45 from both sides. I would get 9b is equal to 135. So divide both sides by the 9, and we get 15. So b is 15. So to find all these values here, well, if I plug 15 into this angle, angle G, then I would get, let's see, 45 plus 25, which will be 70. Right? Okay, because if we plug 3 into here, then that gives us 45 here. We're going to plug or add that to 25, so that will give us an angle here of 70 degrees. Now, once that's 70 degrees, we know that this must be 110 because those two are supplementary. All right. I'm going to substitute 15 into this equation for b, so that gives me 150 minus 69, which would give us 81 degrees, I believe. If this angle is 81 degrees, then that means this angle must be 99. Okay, and when it said find the angle measures of G, H, J, K, that means find all 4 of those angle measures. Okay, so likewise here, I could, if I'm given these opposite angles, then what I could do is just say, okay, the 4x minus 13 plus the 33 plus 6x would equal 180. Alright, so that leaves us with 10x plus 20, again, equal to 180. And I'm going to go ahead and take a shortcut here and just kind of do some of this in our head. Subtract the 20 from both sides gives you 160, leaving us with 16 for x. So if we plug 16 in for x, this angle right here would be 4 times 16, which is 64, and 64 minus 13 would be 51. Now if that angle is 51, then the angle opposite that angle, again, because this is a quadrilateral inscribed in a circle, its opposite angle would be 129. Alright, again, notice we are to find all of these angle measures. Now, this 9x over 2, that is the measure of this angle right here. Well, x is 16, so if we substitute that in, we're going to get 72 degrees. And then its opposite angle would be 108 degrees. And I found that by taking the supplement of 72 degrees. I guess the other thing we could have done there is add these 3 angles together, and any quadrilateral is going to add up to 360 degrees. So I could have added these 3 together and subtracted those from 360. Well, that concludes the lesson. Thank you very much for all of your questions and all of your interest in sharing all your stories. I will see you in class soon.